Hello and welcome to everybody on Cloud Fitness. So in today's video, we are going to see how we can implement linear regression in Pyspark. So in case you have not watched my previous two videos on the machine learning and linear regression theoretical part where I have explained what linear regression is, what we are trying to achieve in the linear regression, I do recommend watching that video first because that is only when this video will make sense to you. So let's move ahead and see exactly how we can implement linear regression in Pyspark in today's video. But also do remember to connect with me on LinkedIn because I will leave the link of LinkedIn in the description box as well. So before moving on to the linear regression hands-on, I would definitely like to show this to all of you so that you understand what we are trying to achieve today. So essentially, whenever you talk about any ML flow, right, whenever you are trying to talk about basics of ML, right, this is the basics which I have noted down on the screen. So if you see, first of all, we will always have initial data set. We will have a data set and the data set will be divided into features and the labels, right? Specifically, I am talking about the linear regression that we are going to see today. Right, so we have set of features, we have to label our data set and get the output, right? So the initial data set it is itself divided into features and labels. Now this data set we try to split into two types of data, right? We try to split it into the training data set and the test data set. Now when we talk about the training data set, right, this is the data on which our model or algorithm is going to train on, right? We will create this linear regression algorithm. Our linear regression algorithm is going to get trained on a training data set, right? And once it gets trained on the training data set, we are going to pass in our test data set, our test input data set, and our model is going to give us the predicted value from it, right? Now, this initial data set, getting this initial data set and, having your training data set and the test data set, this is nothing but it is the part of the feature engineering as itself, right? And then you pass on your training data set to the model algorithm, right? You have algorithm over here, you pass on your training data set, your model gets trained, and then you pass on your test data set to the model and you see what it has predicted. You see what your model has predicted, and then you evaluate as well that whatever your model has predicted, how much accurate it is. So the evaluation part I'm going to cover in another video because that itself is a huge topic in itself. So we are going to cover till prediction over here, right? And this process keeps on iterating. All together. We always try to evaluate whatever, how accurate our model is. Again, if it is not accurate, we will again try to train our model on new set of data, test it. So this process keeps going on. So this is your complete machine learning flow, or the machine learning basics is what you can say. So let's move ahead and see exactly how how we can actually do linear regression specifically in Pyspark. So in this case, what we are trying to do, I'm trying to use first of all Databricks for this particular process. Now you can go ahead, use Jupyter Notebook as well, but since I assume that most of us have come from the data engineering background, right, we already are aware of Databricks, and Databricks itself is a very good platform to learn. So that is one of the reasons that I am using Databricks for all of this work. Now, if you see, when you talk about linear regression, I'll go back to my slide over here, right? You see, I told about the initial data. First of all, I need to have my data ready, right? Now, to get my data ready, I'm not trying to use any data set online. I'm trying to generate the data over here. Now, to generate a data, what I'm trying to do, I'm first of all trying to create an array. I'm trying to create two columns, basically X and Y, right? So using this, if you see, let me in fact zoom it so that you have even better view of what I'm trying to do. So if you see over here, what I'm trying to do is import numpy as np. So using numpy.array, right? Numpy is another library in Python which is used especially when you're working with the arrays. So I'm trying to create two columns X and Y, right? I have randomly provided two values over here. So you can see, print, when I'm trying to use the print statement, you can actually see this is how my X looks like, this is how my Y looks like. Now this is the process that I'm doing to generate the data. Okay, so I have this X and Y. Now once I have these two arrays, right, I'm just trying to find out the mean of both of these arrays X and Y. So basically, whenever we are trying to do whenever we are trying to generate the features and labels, we are trying to generate the training data and the test data, a lot of feature engineering is involved. So when I say feature engineering is involved, trying to understand the data, what is the mean, median, mode, right? Things like that. What is the central tendency for your data? Things like that. You will always want to see the data because there is a reason for it. So let's say in your input data set, let's say you have height and weight, right? Now in this case, you want to predict your weight based on height, right? So usually, let's say your height is 5 feet and your weight is 50. So that is the normal, tendency of your data. But now let's say there is one particular record in your data where for the height of 5 feet, the weight is, let's say, 150 kg, right? Now this will cause a lot of anomaly, right? So you might want to remove that particular record from your training or test data set. So now this becomes your kind of a feature engineering. Now similarly, your models are nothing but the algorithms, right? So they don't want to they don't want to take nulls. So if you have nulls in your data set, you might want to remove it. So all of that becomes the part of feature engineering. So this work needs to be done, right? Now in this case, what I'm trying to do, I'm just trying to check the mean, right? And then I'm trying to understand the standard deviation. What is the deviation that my data has, these values have. Now after that, I'm trying to get the covariance of my data, right? I have a correlation factor over here of 0.8. Now using this correlation factor, I'm trying to get the covariance. Now here what I'm trying to do is, I already have a data set, right? I'm trying to generate the data set based on these X and Y which I have created at the top. Now this X and Y, I am saying that these two are my independent feature. Now X and Y are my independent features, but they have a correlation factor of 8.8, right? So they are correlated because it's usually the best ideal way is that both of your input features are independent, but usually that does not happen. So there can be some level of correlation between both these two factors, between these two features, right? Between your X and Y, there can be some kind of a correlation. So here I am defining that, okay, the correlation is 8, and then I'm trying to get the covariance basically, okay, so I might create a new video on this, but covariance over here, try to understand how my how my Y is going to behave with every change in X, right? So that kind of a covariance we are trying to find here. Now based on that, I am simply trying to create my data set. So if you do, now this is just a data set creation. If you don't want to create your data set this particular way, you can always go ahead and download a data set and work on that, right? So this is just a random creation of your data set, right, where I know what is the mean of my data, right, what is the covariance of my data. So I know that part, and I have generated the data over here, right? Now this is how my data set looks like. This is my X, this is my Y, right? This is my exact how my data looks like. Now if you see, this is my data set. Now if I go back to my slide, now I have my initial data ready, right? Now this initial data, you can do it the way I have done, or you can also get it online. You can take any data set available as well. Now if you see, if I go ahead, now this particular data, first of all, I'm creating an RDD out of it, right? And then I'm creating a data frame out of that data set. Now since I'm working in Spark, I've just created the data frame out of my data set. Now similarly, if you take any data set online, right, in that case also you will have, you can read it as a data frame, and you will have multiple columns, right? So this is how my data looks like. Now after I have this data, right, now the second step is to split my data into the training and the test data set, because I have got this data and I want to split it into two sets of data. One I will use for the training and one I'll use for testing. Now in this case, if you see, remember that here, especially in Databricks ML, you have something called as vector assembler, right? Now this vector assembler basically helps you to segregate your data. When I say to segregate your data, it helps you to identify, what data will be your features, what columns will be your features, what columns will be your input features, and what columns will be your output required, right? So it tries to group your data, right? So without this, if you try to work over here, it is not going to work. It is actually going to give you an error that your data needs to be in a vector format. So if you see over here, what I have done, I have said from pyspark.ml.feature import vector assembler. Now what this vector assembler will do, whatever data I have, it will try to segregate that, okay, these are my independent features, right, and this is my dependent feature, this is my input, and that is my output. So that is what is the use of this vector assembler is. Now if you see what I'm trying to do here, I am calling vector assembler and I'm saying input column X, right? So if you see, I have X and Y, right? I am saying this is my input, right? This is my input column, and this is nothing but this is my feature, right? You can give multiple features as well over here. And then I am calling linear regression over here. Now where I have imported it from pyspark.ml.regression import linear regression. So this is where I have imported linear regression, and I am saying that I need to use this linear regression to label my column Y. So basically I am saying, using this vector assembler, I am saying that this is my input feature, X is my input feature, use this as an input and run linear regression to get the value of my label column, which is Y. So Y becomes my output feature, X becomes my input, right? X becomes my input and Y becomes my dependent variable, right? The output. And then pipeline, right? If you see, I am importing pyspark.ml.import pipeline to use this assembler and this linear regression as well, right? Now after I have this, right? So now if you see, till now what I have done, I have basically got the data, I have labeled it as that, okay, this is my feature and this is my output label. I have segregated it, right? Now after segregation, and I have also said that, okay, I want to apply linear regression on it. Now if you see, now I want to split my data into the training and the test data set, right? Now to do that, I am simply using random split, right? Random split is a random function, right? Sorry, it's not a random function, it's a Python function, right? You already know that. So random split. So on the data frame that I have at the top, I am doing a random split of 75% of the data will go to the training and 25% will go to the testing data set. So this is just the random split that I have done, which you also have seen over here. Now I have my test and the train data set ready. So I have my test data set and the training data set, both of these two data sets ready, right? Now what do I need to do? I need to run my model, right? This is what I need to do. Now in the model you will see that the pipeline that I have imported, right, because that is the pipeline that I want to run, that now if you see over here, I have something called as pipeline.fit and the model.transform. Now here I have mentioned over here that this fit, right, is nothing but it is an estimator. This transform, right, this model.transform, the model basically is nothing but the transformer, right? If you see over here pipeline.fit, right, now what will happen is I have train and my test data set. Now I am saying pipeline.fit and I am putting my training data set in the fit, right? And this fit is nothing but this fit is a method inside my pipeline. Now if I go up at the top and if I see the pipeline, right, what does this pipeline have? This pipeline is taking assembler. Assembler is nothing but it is taking that, okay, this is my input column, this is my independent feature, and LR is nothing but the linear regression model that we want to use to predict the column Y. Now this pipeline will run and it will try to train the model. It will try to train the model used based on my training data set that I am providing over here, right? Now this is nothing but this is what is called as an estimator, right? It uses .fit method and returns a model which is nothing but it is a transformer. Now this transformer is nothing but what it will do is, if you see dot transform, right, it will use this dot transform method, and it will use your input data set, right, whatever you want to give, and it will give you predictions as an output, but it is not going to learn anything from here. So if you look at your command 5, it is not going to learn anything from here. It is just, your model is actually learning from your training data set in your line number 3. Here in line number 5, using the transformer, which transformer always have this dot transform method. So using this dot transform method, it is just trying to basically get you the output, right? It is not trying to learn anything, right? It will just return you a data frame over here, which will have an additional column, and that additional column is nothing but the output that you desire, right? So this is the part where you are training your model, and this is the part where you are actually trying to display the predictions as well, where you have the prediction, where you get the prediction and you can actually use it to see what the prediction looks like. Now if I use display of predictions, you can actually see that it shows something like this. Now if you see your y and x, and also if you see your features and your prediction, now remember that, remember one thing, if I try to expand it, you see your features looks like UDT over here, right? Your feature is nothing but this is UDT. I will explain that. Now if you see y and x, right, this is what your input was, right? Your x was your input, and your y was the output that you have given to the model, right? And then you wanted model to predict it as well. Predict the value of y for every value of x. Now when you have run the vector assembler, so at the top, if you see, you have run this vector assembler, right? This vector assembler. Now what does this vector assembler do? This vector assembler, whatever your features will be, so even if you have 10 features, even if you have 10 independent features, right, you can put it over here. What it will try to do, it will try to assemble your features like this. It will try to create your one column of your all the features. So right now we just had one, right? So you see in the here only one one value over here, but otherwise if you have multiple features as well, it will try to completely group it together as one features that will be given to your model, right? Now if you see this 10.5, right, it is nothing but it is the value of your x. Now if you had two features, it is going to give you two features grouped together under one column. So 9.15, 9.15. So this is nothing but this is the value of your x only. This is essentially the way the Databricks ML will need your input to be. Now if you look at the prediction, now this is the prediction that you have got from your model. So here what you have done is you have trained your model, pipeline.fit train, right? You have trained your model on the training data set. Where is the pipeline, right? Pipeline is what we have defined over here. This pipeline is using your assembler and it is using your linear regression model, right? This is nothing but your linear regression model. Now your pipeline is running using this trained data set, and it is giving you this as the prediction, right? Now this prediction, if you see, right, 8.29, 8.45. If you go to the left, what is the actual value? 7.5, 18.22. So this is your actual value, your y is the actual value, and your prediction is the predicted value. So this is how your linear regression works. Now the next step is basically trying to identify how good your model is, because if you see there's a difference in your predicted and the actual value. Your actual value is 7.5 over here, but in predicted, if you can see, it is 8.2. Here it is 8.4, but if you see the actual value is 18.22. So that is a clear outlier in your data, right? Now this is exactly what we have seen in the linear regression algorithm as well, right? In the linear regression algorithm, we have seen that we have if I draw it over here, we have already seen that in the linear regression model basically tries to get the best fit line, and all the values that your model will identify will be on this best fit line. Now let's say this is my actual value, right? This can be my actual value. So similarly, what you have seen is there's a difference, right? There's a difference between your actual value and your real value, right? So if you see, this is the actual value that you have got somewhere, right? Your actual value was 18 point something. So if I go back over here, you can see 18.22 is the actual value and your predicted is 8.4. So if you see, if you come over here, right, this becomes your predicted value, which is nothing but 8.4, right? So you have what? You have a difference, right? You have a difference over here, right? Now basically your model should be like that, this difference is minimum, right? That is what we have learned in the linear regression. So this is how your linear regression actually works in reality. And after that, I will also make a video on how to identify whether this model, what is the accuracy of this model, right? We will evaluate it. So if you see, we have done this model algorithm, right? We have got this linear regression model algorithm. We have split the data into the training and the test data. We have also predicted the values, right? We have also predicted. But what we have not done is we have not evaluated in this video. We will evaluate it in another video. So similarly, on the same data model, right? On the same algorithm, on the same linear regression algorithm, you can also input your enterprise data, or you can input any other data as well, and your model will be able to predict. Right? And where is your model? Your model is over here, linear regression, that we have imported. Now we have imported our linear regression model from pyspark.ml.regression. So this is exactly how your linear regression works. I hope you like this video. Do let me know in the comment section if you want me to explain it in some other kind of a way, or whether you were satisfied with how I have explained, or you want me to change anything. So I hope you like this particular video, and do remember to like, share and subscribe to my channel for more of the such upcoming videos.